Muy buenos días, damas y caballeros. Les damos la más cordial bienvenida a la Conferencia Técnica Internacional, Sudáfrica, Innovación y Tecnología en Minería. Damos nuevamente el agradecimiento a todas las personas que nos acompañan en esta mañana y nos va a acompañar con la moderación el ingeniero Juan Quiroga, vocal del capítulo de Ingenieros de Minas del Consejo Departamental de Lima, del Colegio de Ingenieros del Perú. También, por favor, precisar que la conferencia va a ser en español y en inglés, y para ello se les comunica a todos los participantes que tienen habilitada la opción de interpretación. La pueden ubicar en la barra de abajo haciendo clic en el icono interpretación, en el icono del mundo pueden elegir el idioma original o en español. Muchísimas gracias. Adelante, ingeniero Quiroga.
Buenos días a todos, buenos días colegas colegiados, colegas todos, estudiantes, público en general y por supuesto bienvenida a la prensa especializada. Esta mañana tenemos la oportunidad de recibir a un grupo de especialistas sudafricanos que nos van a transmitir un poco de sus conocimientos, experiencias y alta tecnología en minería. El que les habla tuvo la oportunidad de trabajar en Sudáfrica en minería y sé de la tecnología de alta gama que han desarrollado ya para poder minar a tantas profundidades. Bueno, entre las pautas que tenemos para este programa del día de hoy, bueno, estaba que el ingeniero Luis Muñoz, nuestro presidente del capítulo, iba a dar unas palabras, pero lamentablemente por motivo de fuerza mayor no está presente. Les pido la disculpa del caso. Entonces pasaremos a escuchar las palabras de bienvenida de don Guillermo Van Goort, presidente de la Cámara de Comercio Peruano-Sudafricana. Don Guillermo, por favor, adelante.
Gracias, ingeniero Quiroga. Buenos días a todos los participantes. Como presidente de la Cámara de Comercio Peruano-Sudafricana desde hace 4 años y como cónsul honorario de Sudáfrica en el Perú desde hace 30 años, me es muy grato participar en este evento del Colegio de Ingenieros de Perú y tratar de exponer brevemente cuáles son las posibilidades de colaboración entre Sudáfrica y el Perú en el tema de minería. Como todos sabemos, Sudáfrica tiene muy desarrollada la industria minera bajo superficie, a profundidad, a unas profundidades muy grandes, y ha desarrollado una tecnología en lo que se refiere a maquinaria y equipos que es muy importante a nivel mundial. También tiene alguna experiencia en la minería de superficie, en la minería de tajo abierto, obviamente producto de esta larga experiencia en la minería bajo el subsuelo. En los últimos años en la Cámara nos hemos concentrado en tratar de aumentar el nivel de comercio entre el Perú y Sudáfrica, y es importante mencionar que ya hoy día hay cerca de 400 empresas peruanas que importan productos de Sudáfrica y hay alrededor de 300 empresas peruanas que exportan productos a Sudáfrica. Y esto está creciendo. Naturalmente ha sido afectada por la pandemia, pero estamos seguros que se va a recuperar en cuanto se recupere un poco más la normalidad producto de la pandemia. Y yo creo que en las presentaciones que van a hacer cada uno de los expositores van a ver ustedes la calidad de los productos y los servicios que ofrecen, y eso va a ser la mejor carta de presentación que podemos hacer. Sin más, le devuelvo la palabra, ingeniero Quiroga.
Ok, muchas gracias, don Guillermo. Bueno, para empezar este ciclo de conferencias de esta mañana, bueno, vamos a tener dos. La primera, el tema va a ser seguimiento del flujo de mineral en la minería subterránea y de tajo abierto en tiempo real. Esta va a ser compartida por Jim Porter, que es un consultor de ingeniería minera de IGH Ingeniería SA. Permítame resaltar algunos puntos del perfil de este expositor, ¿no? En octubre de 2010, Jim Porter fundó Jim Porter Mining Consulting SA. Sin embargo, su carrera comenzó en la compañía Anglo Gold Ashanti, donde ocupó una serie de puestos de nivel senior, como director de producción, director senior de proyectos y director de minas. Actualmente es consultor en ingeniería minera en IGH Ingeniería SA. Bueno, sin más preámbulo, le voy a ceder la palabra a Jim. Será una exposición de 20 minutos y luego podemos pasar a si hay algunas preguntas del público asistente. Jim, please, it's all yours. Please go ahead.
Gracias, Juan. Hopefully everyone is able to see that presentation, first page. Sorry, I just need to get myself set up. What I chose to talk about this morning is a selection of technology built on new levels of digital technology that is available in the world today. But I've selected it because I believe that it is not only suitable for the South African mining market, but it's also very appropriate for the Peruvian mining industry, and particularly the underground hard rock mining industry. And I'll be explaining or sharing with you a little bit of this new type of technology and a very novel approach to the use of the technology. I will try to keep the presentation quite short, but just to introduce the topic, obviously people that are running mines since the very beginning have wanted to understand the amount of ore being produced from the production stopes and how that is moved through the mine to get to the processing plant. Over years, mines have got larger, they have become deeper, they have become more complex because they need to deal with more difficult geotechnical and geological conditions. Changes in social responsibility and expectation means that compliance with laws and safety and health of people have improved enormously, particularly in recent years. And that has added more complexity. And also companies which are listed on the different stock exchanges around the world have got complexity in how they communicate and report to their various stakeholders. And with the invention of computers and digital technologies, there has been a huge increase in various computer-based applications and tools, which are used in both the business side and the technical side of our industry. But the pace at which these changes are taking place is accelerating. I think we all understand that process, and we all feel that process. And a very well-known example is that many, many years ago, when fluorescent tubes were first invented in America, it took nearly 80 years until 25% of the population were using fluorescent tubes. Bring it to more modern times, it took only 4 years from the invention of the iPod until 25% of the US population was using the iPod. And that pace of acceleration has continued with various web-based applications and so on. But if we look at ourselves in the mining industry, around the world, how long have we been talking about mechanizing our mining industry? How long have we been talking about automation? It is only now that we are seeing real ability to implement some of the more advanced forms of mechanization and automation. But it is still only a fraction of the industry which is able to use this sort of equipment. And we're not even yet talking about the sort of robotics and sophisticated automation that we see in the manufacturing industry. We're still many, many years behind the manufacturing industry. Of course, within our industry, there are many vehicles and means by which computers have been advanced through research and development and their implementation. Some of you may be aware of the APCOM organization, which has promoted the application of computers in mining over many, many years. But of course, there is now an increasing growth in investment of what is called the Internet of Things, how to link digitally many pieces of equipment and gain from that ability to have cheap, pervasive technology. But is that making the production miner's life easier or more difficult? Having been exposed to both sides of this world, the technology world and the production world, sometimes in the production world, you get overwhelmed by just too much data. And sometimes you feel that the computer guys are too close to their computers and don't understand the real mining world well enough. So if we try and put this into what we would call a problem statement, the question is, how can existing lower technology underground mines be upgraded and benefit from available fourth industrial revolution technologies to gain safety and productivity benefits without disrupting production with expensive and complex technology upgrades? Over the past 10 years in South Africa, a number of technologies have been developed, and I'm talking specifically about one today. And I want to introduce you to a slightly novel approach to how this technology has been put together. I'm going to be a bit simplistic. Mining has 4 challenges: rock, number 2, rock, number 3, rock, And number 4, yes, rock. In other words, how to break rock, how to load rock, how to support rock, and how to move rock. If mining was just as simple as that, we would all be out of a job. Of course, it is much more difficult. But those activities generally are referred to, of course, how ore and rock flows through your mining operation. And being able to understand how that flows through some complex underground mining operations, such as the diagram shown on the right here, which is only showing a shaft infrastructure. It is not even showing the production mining environment. We can have very complex movement of material from the production phase or the development end all the way through to your main transport systems, be they rail bound or be they tracked or be they conveyor belts, until the material gets to a stockpile or to the extraction plant. Now, the thinking has been that using mine planning and mine resource reserve tools, we know where our production stopes are in three-dimensional space. And we understand many things geotechnically, geologically, in terms of the reserve and the resource estimate of where that material is. And our mine design and planning tells us where, when, and how we want to extract it. Now, you can link all of that data to the rock which has actually been mined today and put in a truck and taken to surface. Think of the movement of that rock as also the movement of the basic data. It implies that your ore flow system is also a data flow system or a data network. And so the thinking is that you can use your logistics system to move data as well, because if you can simply identify a load point in space and time, how much material is picked up and loaded, and where that material is as it flows through the system, you know an incredible amount about the performance of your mining operation. So IGH, together with my company, JPMC International, have looked for particular solutions to assist within our respective countries of operation. We've now joined up with a company called AccuTrack, which our combined resources can deliver, we believe, a proven ore flow tracking, data transport, and production dashboard, and specifically for the Peruvian underground market, but it is also, of course, applicable to the surface mining industry. But we have done a little bit more. We've combined that with a very uniquely built systems analysis tool for optimizing production, so that we use tools like theory of constraints and data analytics to identify where are the constraints in the ability to achieve an operational plan. And
la industria de muebles, si migra a materiales circulares, podría reducir el 50% de demanda de recursos naturales y también podría reducir el 30% en impactos ambientales. Hay una empresa que se llama Steelcase, que solamente se dedica a hacer muebles de oficina, en las cuales...
Sorry, we have... Okay. Right, so very quickly, I'm going to just touch on some of the key aspects of what this solution is able to do. And it's the technology specializes in tracking, recording, and the performance of the equipment which is transporting the ore from the working place through to the surface plant, whether it is rail-bound, trackless, or open pit. And it's then accumulated the production data, it's analyzed, and proactively can assist in guiding managers and supervisors on what plan to put in place to rectify short or medium-term deficiencies in their production performance. I'm going to talk a little bit about the Smart Rail, which is a track-bound solution. And mostly I'm going to talk about the truck track option for underground mechanized mining. But all of these combine to provide better grade control and metal accounting, optimization of the rolling stock or the mining fleet, real-time production management and control, as well as a proactive and dynamic replanning according to daily production issues, as I mentioned previously. So the rail-bound mining operations, and there's still a large number of these in different parts of the world. It simply works on the following basis. When an ore train is depicted here is below the ore loading box or a waste loading box, and these trucks can also be loaded by scoop. That also is quite applicable. There's a transponder inside each of the wagons which talks to the loading point, and it knows it's loading because of motion detectors that pick up the movement of the material when it's being loaded. And of course, it then goes over a weighbridge, and that information is reported to the data acquisition system. And at the time that the train tips, it also, its data is recorded, goes back over the weighbridge, and it gives you a simple volume of mass, which reports from the various loading materials. And these can be in multiple different parts of the underground mining operation. Now, it seems very simplistic, but from just that simple data, the ability to determine and quantify whether your production areas are producing the planned amount of tons and grade is made available through this very simple system. And it is inexpensive and extremely robust and easy to implement. And what is particularly good about it is that you don't need to put in an expensive underground backbone of fiber optics or even what many people are working on, putting in an underground Wi-Fi system, because the data is carried in the actual in smart boxes which are installed on each of the moving pieces of equipment. And so when the data is gathered at this point, you don't need another network, because it measures the time it takes to travel, and it knows the distance from the mine planning system, so it knows what time is taken. And then all the data is uploaded when it gets to an upload point, which would be near your shaft infrastructure. So as I said, beacons are all installed underground. It tracks where equipment is. And I'll show you in a moment. There's a small little video, which I'll show in a moment, which demonstrates a little bit more simplistically how the system is set up. It effectively also gives you a near real-time reporting of what is actually happening during the course of a production shift. So if you just bear with me, this is a very short video.
Underground mining operation, obtaining reliable data on the productivity and location of underground mining vehicles is a difficult task. This process is often highly reliant on manual processes, making it vulnerable to inefficiencies and inaccuracies. Introducing TruckTrack, an innovative digital tracking and weighing solution. TruckTrack is designed to optimize productivity and reduce costs through efficient asset management. Beacons installed underground are read by the single board computers on the vehicles to determine their location, the route they follow, and where they are ultimately tripped. Using an intelligent algorithm, TruckTrack creates a mesh network between the vehicles. The system calculates the probability of the next vehicle driving to the download point. All the vehicles will then upload their data to that vehicle. The system is not reliant on every vehicle driving past a download point. This allows data to appear sooner in the database, making the system near real time. All of this is achieved without the need for costly Wi-Fi infrastructure. The reporting dashboard includes individual vehicle timelines, allowing management to track the movement and productivity of a vehicle from the Sniff Canvas management data. TruckTrack leads to an increase in production as a result of better asset management and more accurate information being made available to your management team. TruckTrack by AccuTrack.
Okay, so that just gives you a little bit of a better overview. And also, as mentioned earlier, there is a very similar solution which is applicable for surface open pit operations. It doesn't make use of those individual transponders because on surface it can make use of 4G connectivity or 5G connectivity. But what is important is all of the vehicles in the fleet effectively form the data network. When there are spots in your surface infrastructure where signals are not strong, the equipment itself carries the data through and transfers it in a network fashion to the closest point for uploading to the production servers. This is all handled by smart algorithms which are built into those onboard control boxes. Of course, and coming back to the purpose of today's and this morning's presentation, I've given you an example of where mining companies were looking at how they could use the smart technologies which have been developed, such as the very, very sophisticated technologies used in cell phones, but how to ruggedize that and use that in a mining context where it is solid, simple to use, robust, and gives a simple access for many mines to be able to leverage off of modern technologies, and to do it in a way which assists the operational management to better understand how their daily production is progressing, and also be able to analyze the information back in the mine planning environment to understand where the shortfalls between planned grade tonnage mix and what is actually achieved from underground, and understand where the value is actually in the business. And to assist with that, we have these very good tools that we use now to take the real-time production data and use it in a very quick and simple way to understand and point us to how to set up the tasks for the next day or 2 days, so that we don't lose time if we've had any disruption to the normal productivity and production operations. None of this works, of course. None of the technology works well without people. If you're investing in the technology, you must invest in people as well, to invest in their training and make sure that they understand how the use of the technology is to their advantage as well, not just to the business advantage. Everybody has to feel that, that they are part of creating an improved safety environment and production environment. And people in technology create innovation, and innovation leads to the projects. People and systems through which they do their work, it also equates to productivity. And productivity is what management has to focus on to sustain and maintain the viability of their operation. And of course, innovation and productivity has to equal a lower dollar per ton. A lower dollar per ton is sustainable mining. And of course, I'm in business, and myself with IGH, we would like to be able to work with the industry out there to achieve that longer term sustainable mining. We really think that in the context of solutions for South America and particularly Peru, that we have hit upon a level of technology which is really appropriate for our Peruvian mining industry. Ladies and gentlemen, thank you very much for your time and attention.
Muchas gracias, Jim. Thank you very much, Jim. Mary, ¿hay alguna pregunta?
Las preguntas al finalizar, por favor, continúen.
Ya, el señor ya acabó, por eso vamos a pasar a la siguiente sesión.
Sí, al finalizar, sí. Por favor, indicar a todas las personas que están presentes que pueden hacer sus preguntas a través del chat que está en precisamente la red del Zoom. Muchísimas gracias.
Ok, Jim, las preguntas, sorry, Jim, the pregunta is going to be at the end of the other presentation, okay? Okay,
sí.
Well, let's see. Okay, bueno, dando las gracias a Jim Porter por su presentación. Bueno, las preguntas las tendremos al final de la próxima presentación. Ahora, continuando con nuestro programa, tenemos el tema, el sistema Asher en la minería, ¿no? La experiencia de Somerset en la mina. Esto va a ser expuesto por 3 especialistas. Tenemos al señor Henry Thompson, presidente ejecutivo de Somerset Group, al señor Vivek Jan-Persad, gerente de desarrollo de negocios, y al señor Quinton Austin, jefe de gestión de aguas residuales. Vamos a resaltar un poco su perfil de cada uno de estos expositores. Henry Thompson, desde diciembre de 2012, Henry Thompson forma parte del consejo directivo de Somerset Group. Es un especialista en finanzas para el desarrollo de negocios, con un enfoque particular en el sur de África, donde ha trabajado exitosamente durante los últimos 30 años. También colabora en una serie de organizaciones benéficas en toda África y es un conferencista muy solicitado. Es presidente ejecutivo del grupo Somerset. Vivek Jan-Persad, desde febrero de 2020, forma parte del equipo de Somerset Group como ejecutivo de desarrollo de negocio. Es un especialista en proyectos de ingeniería y soluciones con un enfoque particular en África también, donde ha trabajado exitosamente por los últimos 12 años. Actualmente es gerente de desarrollo de negocio del grupo Somerset. Y por último, por eso no menos importante tampoco, es Quinton Austin, formado en ingeniería química, ha desarrollado una gama de habilidades, conocimiento y experiencia en la industria de energía, petróleo, gas y química como tecnólogo, gestor de proyectos y analista de procesos. Actualmente es jefe de gestión de aguas residuales del grupo Somerset. Bueno, sin más preámbulo, voy a darle pase a Henry para que empiece con la presentación. Henry, are you going first, Henry? Hi, Henry. Can you hear me? Are you going first? or Vivek?
Yeah.
Yeah, okay, you can go ahead, please.
Thanks, Vivek.
Okay, so Henry, you can start. Yeah.
Yeah, no, carry on, buddy.
Okay, so good day to everyone, and thank you for this opportunity for us to present to you Somerset Group. As some of you may know, we are involved in the ASHA, which was one of the topics of discussion, especially regarding the mining sector. But in today's presentation, we would like to touch on a number of different service offerings we have at a very high level, just to give you a summary of what we can offer. And within that time frame of 30 minutes that we have, we would like to share as much information as possible, and also then look at any questions that we may have as well. So in terms of the Somerset Group, the Somerset Group focuses on a number of products and services. We focus on renewable energy, LED lighting. We look into the water, medical, as well as smart agri and technology. So in terms of this, we also look in terms of the mining, we're looking into the construction and engineering, as well as rental contracts. So in general, we focus a lot on various industries, but our technology and our information and our product supply into the mining is quite diverse. We offer a number of solutions, including equipment rental, including equipment sales, supply and servicing. We have service engineers, technicians, and also provide a range of solutions for the mining sector. For example, like the previous presentation, it was very well conducted, and I must applaud you for that. It was a fantastic presentation with good material. We also offer some similar type of offerings, obviously not the same, but we offer similar type of offerings with bulk material handling, RFID technology, as well as mine vehicles, avoidance collision systems, as well as tracking systems within the mining sector, particularly underground and above ground for mining environments. Including the services that we offer for the mining sector, we also offer a range of products, everything from your rotating machines, your electrical components, your pumps, your water supply, your reticulation systems, as well as the management and the disposal of waste, which is one of the topics that we will discuss in today's presentation. So for today's presentation, we've highlighted a few topics, one being the management of waste, which is known as the ASHA system. We're looking at water recovery and reusability. We're also then looking at bio-to-gas technology or waste-to-energy systems that we will provide some information on. Again, as I've mentioned, there's a lot of information in this presentation. However, we will go through it at a very high level, but also look into it for further discussion at the end of the presentation, or you are welcome to contact us beyond this time frame as well. So I'd like to also point out Somerset Group is also focused a lot on training and skill development. We also put a lot of effort into giving back to the community. So everything that we do within the organization and the business, we obviously adhere to a lot of the social and economic responsibilities within our areas of work. So if we are operating in a country like Angola, as an example, we will ensure that we do a lot of work for that country and support the local community and also give back to that local community. Irrespective of the country, wherever we are associating ourselves with any form of product and projects, we do look at this as a key factor of what we stand for as a Somerset Group. So I'd like to start off by asking Derek, who will run through a lot of the presentation regarding the electrical systems, the electricity to power plants that we can offer you in the mining sector. Derek, you can take the lead.
Thank you, Vivek. Right. Every mine has a lot of waste, and this is something that we've been focusing on in South Africa, looking at the different waste streams and how we can actually turn that into something that's positive for each one of the mines. So for some mines where they have a lot of used engine oils and stuff like that, it's been quite simple, where we've been able to sort of turn that back into energy using, so it's all part of a waste to energy process. And because a lot of the mines are also very short of electricity. And in South Africa, we experience things called load shedding, where there's a shortage of power, and the downtime for the mines is very, very expensive. So we have been working on solutions to actually prevent that type of issue taking place for a lot of them. So in regards to the waste from coal fines, we've perfected that to take coal fines from the coal wash plants and turn that back into electricity using a gasification process. We've also perfected from tires, plastic, general waste, and we've got multiple types of systems that we've worked with over the years. So right now, a lot of our focus is on gasification. So if you have a look right now at your mining waste, there's a lot of tires as well that you have a problem with. And, you know, some of them go back into pyrolysis, but most countries, they just stockpile it somewhere. And yet that's a fantastic energy source that we can look at. Can change the screen, please. Now, as you know, that every country around the world that's signed on to the Paris Accord is all getting carbon taxed, and you know, depending on the size of the mine, if you know, you've got to do special reviews on your carbon emissions and stuff like that, and these things are all costly. So we've worked on different ways to make mines a little bit more carbon neutral, where they have larger tracts of lands where we actually look to rehabilitate that land, and we grow a energy crop, which actually then can go back into the system to create power using it's a biomass type of product, using a sorghum, it's what they call an African grass. And this sorghum will actually generate, you're replacing coal, you're using 1.2 tons of sorghum, and you're replacing 1 ton of coal, depending on the quality of coal. In fact, the sorghum can outperform coal in some worlds, in some countries. Now, with that in mind, obviously, now you're growing an energy crop that there's carbon capture that you can get carbon credits on, and also because like sorghum is a C4 energy crop, the fact of the matter is that you are now using green energy, which helps you to offset your carbon taxes and helps to make you carbon neutral. So there's amazing opportunity when one looks at all of this waste to energy and growing an energy crop for the benefit of your goals to become carbon neutral. Next slide, please. Now, waste plastic and tires, when one looks at coal as an energy source, you know, coal has a calorific value between sort of 19 and 30.5. If you look at your tires has a calorific value of 32.5, so it's higher than coal. Then plastic has a higher calorific value than that, as it goes up to 40 to 46. Now, this just means that there's a lot of opportunity in regards to taking waste and producing a energy that can help run a mine or a city, and that's important. Otherwise, these waste materials end up in landfill rotting for 400 years, emitting methane and other nasty gases into the atmosphere. Next slide. So when one looks at power generation, okay, you've got different types of incineration systems, and you also got different types of turbines and engines that you can run from waste to energy plants. And from our side, we have secured the distribution rights for a few different turbine ranges, from your steam turbine, and then we also got the waste heat recovery, which I'm going to cover just now. And we've also we're looking at low revving big diesel engines that are converted to the syngas that you create from gasification. The nice thing about those is that you can do smaller plants, and they're easy to set up and to run. And you know, so we've got lots of international partners that we've worked with over the years, and we've secured the rights to these things, and we've helped them develop their ranges further with some of the intellectual property that we had that could help them. And the nice thing about some of our systems that they, you know, if you look at a lot of steam turbines out there today, they actually run and use a hell of a lot of water. So our systems are closed loop. So we're capturing the water back from the steam turbine back into a condensation process, back to be reused again. Next slide, please. Okay, so again, we're just talking about calorific value here. And if you have a look at the different sources of energy that you have on a mine. So I'll give you just an idea. Your typical waste oil that you have will more than likely sit with a CV of around about 40. Now we've designed, built our own little turbine system that we're currently running on waste oil, and we can run up to, on that little one that's been running under test at the moment, we can produce up to 500 kilowatts from one little turbine, and it will use in the region around about 7 to 15 liters of used oil an hour. So very efficient. And it just goes to show that, you know, with a lot of your big mining projects, you know, the one mine we're dealing with, they've got 50,000 liters of used oil a month. So taking that and selling it for 50 cents back to the guys that will collect it is not worth it. We'd rather turn it into something that will generate a lot more power for them and help them to reduce their reliance on diesel and the diesel generation side. So another thing is also talking about the calorific value. The biomass that we have run tests on over the last 4 to 5 years, we are getting a CV ratio of about 25, which is equivalent to the third grade coal that South Africa sends out to the world, and that supplies countries like Mauritius. So already we have got a project for Mauritius to grow the sorghum and replace their sugarcane side and supply them the power so they can go green, completely green, and avoid the carbon taxes that they would get for running the coal-fired power stations. Next one. So waste heat recovery systems. Now, again, you know, heat is a waste. So if you're running a coal-fired power station, a lot of that, the energy is going up through the chimney and going into the atmosphere. This can be captured by installing a secondary heat exchanger, and you can capture that energy to put it back into a system that can create power. Now, we've got two types of waste heat recovery systems. One is called an organic ranking cycle. This system will operate in the temperature zone of about 209 degrees, which is very, very low. And you could put multiple, it's only a 200 kilowatt system, but you could put multiple onto a cement manufacturing plant or a a normal coal-fired power station, or anywhere where there's coal being burnt or biomass or biogas being used. So then we also use the organic ranking cycle system, which works on your refrigerant gas. These systems operate between 80 degrees centigrade and 150 degrees centigrade. So you're taking the waste heat coming from even big generators that are and you put the system in between the radiator and the motor, and you take that heat and you can actually recover it back into electricity to power up your smaller sort of factories. These little units only go up to about 125 kilowatts before you're going into a much better, much more different design. So therefore, small scale applications where there's a lot of waste being thrown away, and I think they are essential little commodity because, you know, again, waste heat is a resource that we should be looking at. Next one. Okay, so again, we're talking about the waste heat. You know, it's basically, if you have a look at waste heat in itself, how many manufacturing plants have you got there? Your breweries that are using a lot of steam. You know, you can actually use that, use those same boilers, put one of these systems in, and it can help offset the carbon emission side of things, and because you're generating clean power. Just so many nice little facets that you can look at with this. Also, you know, with our systems, we can show you the financial model that you can get finance for it and do your purchase power agreements with clients so that they can pay a monthly fee for the system or buy the power from you at a monthly fee that is less than what they're currently paying. Next slide. Okay, so your economic and environmental implications, you know, every thing that you have in your country and in the mines, you're looking at different ways to make things more efficient and to become more carbon neutral and to offset the damage that mining does create to the atmosphere. So when we look at all of these systems, we look at this holistically. So we come up with solutions for every single mine. So we have a sort of idea where you send us your waste profile, you send us your waste heat profile, and then we can give you the exact type of technology that you need to be using. We can implement the whole project and even come up with sometimes we can also come up with the funding even for international projects. So if you have a look at the reliability of the technologies that we have that I just mentioned to you, it's closed loop. So you're not getting impurities into the system. So the things, you've got a longer lifespan of these technologies. The turbines will give you up to 30 to 40 years. The organic ranking cycle is a life expectancy of 20 years. And so is the axial turbines. Now, the common applications that we look at right now. So, your biomass, biogas. We've just designed a whole biogas system for Mbari in Zimbabwe, where they're going to take all their waste food and product from the vegetable market to create energy to run the vegetable market. We have also specialized in pyrolysis, where we've done gasification side, right, linked to the pyrolysis side. So we've also perfected the way to remove sulfur out of used oils, which as nobody else has been able to do apart from using high pressure hydrogen chambers. And we've got a number of different ways of actually generating energy. So you can just see from here, from industrial waste heat, power generations using engines and that. We've got we have specialized a lot in used oils, from creating a low sulfur diesel through to creating your syngases from waste. Next page, please. One of our sister companies has been working on creating cement from fly ash. Now, before this meeting, I actually did a little bit of research on your country, and you're currently doing about 1,267,000 tons of coal a year for power generation. Now, from that, you're going to get a 25 to 30% byproduct, and that's going to be a product called fly ash. Now, fly ash has all types of nice little things in it that we can use a polymer, and we activate it, and it can become a cement. We've perfected this over the years, where we're now creating 100% cement-free cement using fly ash and a polymer mixture that you can just mix with you get in a normal bag that you get a bag of cement in. You mix your water with it and your sand and cement, and you've got your concrete. So we have been working with this for quite a while, and a lot of projects have taken place throughout South Africa. And our partner in this, Cyril Atwell, is he is ultimately the leading scientist using polymers in the world, and the first to actually create 100% cement-free concrete. And the nice thing about this is 95% reduction in your carbon emissions from your cement. Next slide. So if you look at the production of cement, you're producing 350 kgs of CO2 just making 1 ton of cement. So, the build industry contributes a massive part to the carbon emissions for the world, and taking that 1.2 million tons, and you got maybe 400,000 tons of waste fly ash. You can actually turn that into a beautiful cement and help build your economy and your country, and not put it into landfill, because it is full of heavy metals, which has still got a secondary poisoning effect on the planet. So what we do is we would actually do a test on your fly ash, and then we'll tell you exactly which geopolymer to use. Now, a lot of projects have been done. One of the more famous ones is the Gautrain in South Africa that was done for 2010 World Cup soccer. So all the pillars and the concrete work that was done for the Gautrain, that was done with a large amount of geopolymer, but it was one of the first ones, so it was not done as 100%. Next slide. Funny enough, the tallest building in Cape Town, one of our pride in our cities, is basically running on, that building was built with 85% cement-free cement using a slag and fly ash, and it's still standing perfectly, no cracks. So that's a good sign there. Next one.
Thank you, Derek. So we now have Quinton that will be running through a lot of the water treatment processes that we offer from Somerset Group. Quinton is the head of water and waste management for Somerset. Quinton.
Thank you, Vivek, and good morning, gentlemen. Can everybody hear me?
Yes.
Yes, thank you, Quinton.
Okay. As I've been introduced by my colleagues, my main focus is on the provision of, saving of, treatment of, recycling of, and repurposing of water. I have a famous saying amongst the group that water as a resource is not able to be used as a once-through process. It's far too valuable for that. It must be reused and reused and reused as much as possible. The particular aspect that I would like to address at this webinar today is mine fissure water treatment. Now, in South Africa, we are generally a dry country. We receive about 46% less than the average rainfall across the world, which would be the average rainfall across the world. So you can imagine we are a dry country. We go through stages of drought quite frequently. And then the saving of water and the treatment of water and the reuse of water is vitally important. Obviously, South Africa is a big mining country and a large mining industry. And it's an inevitable fact that when you dig a hole in the ground and when you mine, and the deeper you go, you will find water, and that water seeps through the cracks and starts to flood the mines, and then has to be pumped out of the mines to keep the mines viable. This is mine fissure water. Unfortunately, mine fissure water is contaminated simply because of where it comes from, and possibly also the mining operation itself, with a range of contaminants that are then not able to be, how would I say it, then the water is not able to be used in a normal drinking water application or even a processed water application. I did a project for a company some years back through a consulting firm where we treated the mine fissure water to what we call SANS 241, which is the South African potable or drinking water standard. Now, you must understand that this mine is a gold mine out on the west side of Johannesburg. And our gold mines and the water from gold mines are generally contaminated with a range of heavy metals, such as cyanides, arsenic, uranium, and a range of others. And of course, to get that water to a potable level is a bit of a challenge, but it can be done. It can also be done economically and within the costs that potentially you would be facing to buy in water. This particular mine was Sibanye Gold Mine. It was the Kloof complex where the Kloof shaft is. And it consisted of the following basic process stages. Obviously, coarse filtration. It was normally a dual media sand. That was just to get out the larger suspended solids. Then you pH correct it, and then to a pH range where your flocculation and your coagulation step is best suited. Flocculation and coagulation is the addition of a chemical, something like aluminium sulfate or a polymer of some sort or combination of both. And this then causes the particle charge on the suspended solids to decrease or increase, sorry, such that they start to coagulate together. And as they coagulate together, they either float to the surface or sink to the bottom. And then you create a clearer water. Once you've done that, then you can put it through an ultrafiltration process. Now, ultrafiltration is not reverse osmosis and it's not microfiltration. Basically, you have different ranges of filtration to remove different particle sizes. And ultrafiltration is used in this application simply because not only will it remove the flocculation and coagulation particles, but it will also remove certain of the suspended and dissolved solids that would be damaging to a reverse osmosis stage. So you pass it through an UF system, and now you've got a pretty clear, what we call supernatant flow, that now then goes to a RO stage. Reverse osmosis is used around the world for a range of treatment options for water treatment. And you've got to be very careful to select your RO membrane and process such that you are addressing the required water quality and removing what the RO membrane needs to remove. RO membranes are also very fragile, and they can blind up and they can clog up quite quickly. So you must make certain that your steps beforehand, and in this case, we're talking about our coarse filtration, pH correction, flocculation, and ultrafiltration, are done in such a way that you minimize the damage or the potential damage to your RO bank. Having done that correctly, your RO bank will last a long time. It won't require a lot of flushing and cleaning. And as normally the case, because when you flush and clean an RO, if you put a cubic meter of water through an RO system, generally you will get anything between 50, 60, and if you're lucky, 70% clean water on the other side. The other 50% or less is used to clean the membrane surfaces themselves. But if you do a proper pre-treatment, then that can start to reach above 80, possibly even 90%. Now you need to recreate your pH that is suitable for drinking. And generally that's in the 6.8 to 7.2 range. So you have a pH correction step after your reverse osmosis stage. Now you've got effectively drinking water, but you need to disinfect it. All the other steps prior to that have basically removed the microbiological contaminations and viruses and anything that might else be in the water that would obviously be a danger to human health when it's consumed. And my preference is a UV combined with ozone, which is called advanced oxidation. There is absolutely no living organism that's known to man that would be able to withstand a UV and or ozone treatment application, and the microbiological contamination will definitely be removed. If you require some residual disinfection to remain in the water because you're pumping the water a long distance and it's going through a large reticulation system to the end users, you can put a very, very small amount of chlorine in, because what will happen is you've already removed all the contaminants that the chlorine would normally be attacking. As such, this remains in the water and travels through the reticulation system to ensure that your sterilization and disinfection of the water remains at 100% to the endpoint or to the user. You might want to do a final filtration step afterwards. It's not always necessary, but we did in this particular case. This particular plant was a 3 million liters per day plant, and it provided 30% of the drinking water requirements for the Kloof mine complex. They use approximately 10 million liters per day, and since I have left that consulting company in that particular project, it's now been mooted to expand the plant to take up the balance of that requirement. So it's been a successful project, and it bodes well for future mine water reuse and savings, because acid mine drainage from mining operations is a huge problem if you don't get rid of the water and treat it properly. And it affects groundwater, it affects a range of other water sources, and is very difficult to go further and use that water. I think that's the only slide I have. Vivek, is that correct? Vivek?
So we've got
okay.
The ozone-based treatment as well as
That's,
the
okay.
yeah.
All right.
Yes.
So just a little bit on ozone-based water treatment. First of all, people think ozone-based water treatment is new. That's not the case. Ozone was first used to treat water in 1903 in France, before the First World War. The difference was, or the difference is that the generation of ozone has been difficult up until approximately, I would say, 30 to 35 years ago. And the generation technologies have improved to such an extent since then that you can now have ozone generators generating anything from a couple of grams an hour to hundreds of kilograms an hour. And yes, they're still expensive pieces of equipment, but they're very reliable, and they don't use a lot of power. Effectively, what you do when you generate ozone is you basically can either use dry air or you can use oxygen. Oxygen is preferable because you can get a higher mass percentage of ozone in the exposed gas. Dry air works quite well as well, but you get a lower percentage. Having said that, you pass the air or the oxygen through a reactor, if you could call it that, where you have a positive and negative current applied. It's high voltage, low wattage. And what you create is effectively a lightning storm in a box. You create multiple plasma discharges inside the reactor tubing, and the gas flows through these these plasma tubing, these plasma discharges, and then splits up from from molecular oxygen into atomic oxygen, and then recombines as triatomic oxygen, which is the scientific name for ozone. But it's very unstable, and this is how you basically use it. It wants to break down back into its lower energy form, which is oxygen, and it does that by attaching itself and oxidizing, or basically reacting with every single known organic compound that you can possibly think of. And it can also oxidize chlorine, for that matter. It's far more powerful as an oxidant than chlorine. On top of which, it will also oxidize certain heavy metals in a water solution. So things like iron and manganese, which are not heavy metals, but they have a particular problem in terms of water treatment, in the sense that they give water a bad taste. It oxidizes cyanide, it oxidizes arsenic, it oxidizes a range of other metals, such that you can use ozone not only as a biocide, but you can also use it as an oxidant to remove other inorganic contaminations that you sometimes find in water. The nice thing about ozone is, unlike chlorine, for example, which is obviously the most common used microbiocide, is you generate it on site. In other words, you have a water treatment plant, and at that plant itself, you'll have your ozone generation plant and your gas treatment plant. In other words, your plant that provides you oxygen or dry air. And you generate it on site. You only use what you need. There's no wastage, there's no storage. And as a result of that, there is cost savings and a great deal of, operational savings as well. Ozone also aids in the flocculation and coagulation processes in water treatment. So immediately you would use less flocculants and coagulants. And as I mentioned before, UV light and even hydrogen peroxide combined with ozone is called advanced oxidation processes. And these AOP processes are used where obviously they're needed. It's almost like putting ozone on steroids, and it works even faster and more efficiently. As I said before, ozone is generated on site via your dry or oxygen feed gas, and no storage of chemicals are needed in the much lower related hazards. But that's the other slide I was thinking about. Thanks, Vivek. I think that's my input so far, but thank you so much, everybody. Any questions I can deal with at any time in the future.
Welcome. Thank you, Quentin. So for my part of the presentation, as much as the overview of Somerset was done, the focus for my presentation at this point is the ASHA. So the ASHA is a system that makes use of the pyrolysis method. So what the ASHA does is basically it reduces waste into ash, non-hazardous, non-harmful ash. And the system that we're looking at itself is known as the ASHA. As I've mentioned, it operates on the pyrolysis method. We have three variants to this machine. We have a 2-ton solar, a 2.5-ton solar, 2.5-ton electric, sorry, and a 4-ton electric. When you look at the solar powered unit, we have what we say is 70% vapor coming out of the exhaust and 30% non-hazardous white smoke. The reason for this is the difference between the solar system and the electric system is that the solar system has one filtration bank, whereas the electric system has two filtration banks. So you'll find on the electric systems, we have two filtration banks that as a result give us a smokeless system with 100% capacity, or minimum capacity in terms of waste disposal per day. So if you're looking at a 4-ton unit, the idea behind it is that at full operation, the minimum amount of waste it can dispose minimum. The 4-ton system are able to reduce the waste or dispose waste up to 8 to 10 tons because of the content of the waste. Of course, the system itself has a lot of internal components that are operating, but the most important internal component for this particular system is the plasma generator, the plasma reactor. So as I mentioned, the system operates on a pyrolysis methodology or system. And as you can see here, this is now the chamber where one would insert waste. So in the mining environment, of course, PPE is quite hazardous and non-hazardous material that could be dangerous if obviously left in the wrong environment. This is the sort of machine that will allow you to dispose of it very safely and on site. System. So the only rotating or the only electronic or electrical equipment that requires electricity to operate within the system is the 3 circles we look at here. These are the 1 pump and the 2 extraction fans. The system itself uses all of the waste inserted into the chamber that has no oxygen, therefore no flame and no combustion. This waste that is inserted due to the plasma reaction, the plasma process, utilizes the energy generated here to feed the process and to basically fuel the process. So no external is required, no diesel, no, and it only uses a minimum amount of electricity only to power those components as mentioned. So the unit has got a patent approved in Malaysia, China, Australia, and a number of other countries that we've applied for. The technology itself complies fully to the US EPA standards, meaning we adhere to all of the regulations and rules regarding emissions. All of this can be provided in terms of test reports to verify exactly where we are in terms of the EPA standards for the device itself. As mentioned, the discharge from the unit has no secondary contamination, meaning that the ash that is exit the system is completely free of any contaminants or any hazardous chemicals, items, or any form of danger, let's put it that way. So there's absolutely no hazard from the ash that we receive out of the ASHA unit. It does not require any fuel, diesel, or gas to operate. It runs on the waste itself that generates the heat via the plasma reaction or the pyrolysis process. The system itself is very quick and easy to install. It's very automated in terms of it's very applicable to many environments. So when we look at the ASHA itself, this is the unit. This is the representation of the 4-ton or the 2.5-ton. They have the same layout. As you can see, it's quite a sturdy, very robust system. very minimal electronics required. The reason for this is because the system and the deployment of the system is meant to reach very far ends of the earth, hoping that it gets to as many places as possible. So the idea behind it is to make it as easy to operate as possible, allowing us to employ and create job opportunities for less skilled or underskilled labor that we can obviously now upscale into the Azure program, make operators of this unit. The only operation that is required from the operator's perspective is to start up the machine and to ensure that it's always filled every 30 to 45 minutes with waste, so that the machine itself can operate consistently and obviously provide the desired result at the end of the day. So the idea behind the Azure is quite simple. It can be used in a variety of areas. It can be used in airports, landfill, dumping sites, where we have plastic problem issues on islands, as well as where we have some form of disaster. Of course, in this particular discussion, we'll be referring more to the mining sector, but again, some of these areas of waste are applicable. For example, you will have plastic waste on certain mines. You will have a lot of waste going from the mines to the landfill, as an example. So this is a more responsible way of reducing this waste into ash. But the ash itself is not just thrown away. It's definitely able to be reused. It's reused as cement additives, fertilizer additives. It's used to build bricks and obviously other types of brick type environments. However, the ash itself cannot dispose and reduce waste such as bricks, glass, cement, and the heavier metals. However, we have other solutions that we can offer you for that type of application, but this is more in line with the general waste that one would be exposed to. As we know, in the last, say, 2 years or year and a half, the world has been exposed to a lot of additional medical waste. A lot of additional medical waste is ending up in areas that it should not, obviously causing a lot more problems than it should. We have a responsible way of disposing of this, again, with the Azure. Everything that goes into the Azure is completely sterilized and comes out the other side with no hazard. We've even got a customer that utilizes the Azure purely to dispose of syringes, where because of the process, all that's left at the end of the process is the stainless steel needles that do come out sterilized, because the Azure operates between 800 to 1200 degrees Celsius, making it a very firm environment for sterilization. However, the needles are then taken from that process and then sterilized further and sold back into the medical industry. We can also utilize this for the general PPE, your masks, your coveralls, your overalls, etc., any material waste that we have, as well as food. We're able to handle up to 70% of moisture content within the Azure system. Of course, we do not permit or do not suggest you pour liquid into the unit itself on its own. But if you have a lot of moisture combined with some solid waste, of course, the Azure will be able to handle it, provided it does not exceed the 70% threshold. So the Azure unit itself is basically a system that is helping a lot of companies in South Africa and around the world to take zero to landfill, which seems to be the slogan around many organizations globally right now. And the idea, again, is to dispose of the waste in your facility, or have a facility that can adhere to resolving your waste problem. The other factor regarding the Azure, because of the general waste and the consumption of the waste in the Azure system, you're not required to segregate the waste. Of course, a lot of clients would like to separate the recyclables from the non-recyclables. By all means, that is still applicable. You can do that, but the Azure is there to dispose of all of the items that are non-recyclable. Where you would normally take to landfill, we are saying, let us stop taking to landfill, because the landfills that we have around the world right now have a certain capacity. And I think in South Africa, we've reached our capacity. And in many other countries around the world, we're hearing the same feedback, that the landfills cannot take any more waste. So in South Africa, a lot of the waste that would go to landfill is now being diverted. And the challenge that we're experiencing moving forward is, where will this be diverted? So we've got a solution that can assist all companies to reduce what they're sending to landfill, and also then create a circular economy, allowing further employment of people and skilled laborers and unskilled laborers. So that brings us to the end of the presentation regarding some of the solutions we offer. I would like to just add on top of what we've discussed today. Of course, we do have a number of other technologies and other solutions that we would like to bring forward, but we can discuss that if required beyond this presentation. And please feel free to contact us. And here's our contact details. Thank you, ladies and gentlemen, for your time and for listening to our presentation. Thank you.
Ok, muchas gracias a los especialistas expositores de Somerset Group. Muy interesante toda la tecnología que tienen disponible para la industria minera, ¿no? Bueno, ahora procederemos a pasar a absorber alguna inquietud o pregunta que tenga el público que se ha conectado a las conferencias. Jim, hay una pregunta para ti. La voy a leer en español para que las señoritas lo traduzcan. Tecnología ayuda mucho, por supuesto. Sin embargo, algunas veces nos olvidamos de mejorar nuestras prácticas de gestión. ¿Qué es lo que usted piensa acerca de esto? ¿Qué hay de nuevo sobre este aspecto?
Sí, gracias, Juan. Es más importante, ¿sí? I mentioned in my presentation how important people were, particularly when it comes to implementing or introducing new technologies. When it comes to management practice, I have many years of experience where technologies have never fulfilled their objective because the managers who are responsible for an area of operation have not been educated in what to expect the technology to deliver for them and how they can best get value out of the use of that technology in their area of operation. And here we're talking about a range of management and supervisory levels. I'm talking about them all together. So investing in people includes investing in management. On a simple basis, a rule of thumb that I have always worked by is that if you spend $60 on a technology and the development and the deployment of a technology, you must spend $30 on training of the operators and $10 on the training of the management on how to get the best use out of that new technology. I hope that answers the question.
Ok, muchas gracias, Jim. Señoritas, ¿alguna otra pregunta que tengan lista? Ok, debido a la diferencia horaria, este ciclo de conferencias del día de hoy se ha transmitido en la mañana, hora de Perú. Y lo que vamos a hacer es, mañana en la tarde y en la noche será retransmitido, se ha grabado el video, para que más gente tenga la oportunidad de poder chequear toda la tecnología, la alta tecnología que tiene Sudáfrica, que es aplicable a la minería, ¿no? Bueno, solamente entonces nos queda agradecer a Jim, a Henry, a Vivek y a Quinton por sus excelentes presentaciones, ¿no? Es obvio que Sudáfrica ha desarrollado su propia tecnología y es algo que nosotros podemos tratar de aprovechar y adaptarla a las condiciones de Perú, ¿no? Disculpen, acaba de entrar una pregunta un poco tarde. La voy a leer, por favor. Va dirigida para el grupo Somerset. El ahorro de energía es otra área de enfoque para las minas. Y los sistemas de refrigeración subterránea son uno de los mayores consumidores de electricidad. ¿Qué soluciones ha desarrollado para reducir los costos de consumo de electricidad utilizando diversas tecnologías y cambiando el consumo de energía a horas de menor actividad?
Derek? Derek? Is he there? Have we lost him?
Yeah, no, I'm here. Sorry, guys. I'm just doing a Google Translate quickly. Sorry, because I didn't get that.
Yeah.
It didn't translate it for me.
Okay. So you're
I can repeat in Spanish, so the ladies that is doing the interpretation can translate it. Hannah, please. I'm going to repeat the question. El ahorro de energía es otra área de enfoque para las minas. Y los sistemas de refrigeración subterránea son uno de los mayores consumidores de electricidad. ¿Qué soluciones han desarrollado para reducir los costos de consumo de electricidad utilizando diversas tecnologías y cambiando el consumo de energía a horas de menor actividad?
Sorry, guys. Again, for some reason, my Zoom isn't doing the Google Translate.
no, there was no translation. Yeah.
Mary, ¿puedes chequear esto de las traductoras, por favor?
Sí, por favor, vamos a tratar de resolverlo por interno. De todas maneras, podría continuar con la siguiente pregunta mientras resolvemos, por favor, el tema de la traducción. Muchas gracias.
Okay,
Yeah,
so the
Derek,
geometry of the specific geopolymer can be obtained from that of residuals. Yes, a lot of the geopolymers that we're utilizing and activators for the fly ash can come from a secondary waste like spent lime that we get from the Mondi paper mill. So every time we in a lot of cases we're combining different waste streams with each other to produce the cement required. So one of the projects that we're working on now is for the our Sanrail roads department, where we're replacing the lime that they use using a spent lime which has no value, but once mixed with the fly ash, they react together to create a lime replacement which is stronger than your traditional road stabilization side. So yes, I think if I've answered that question correctly, I'd be surprised.
Okay, thank you, Derek. Let's wait a couple of seconds to see if there is any other question coming in, please. Okay, I want to say the last words about this presentation in Spanish, and I hope they translated. Bueno, a todos los asistentes, muchas gracias por haberse hecho participantes de estas conferencias. Es obvio que para poder minar a profundidades como las que hacen en Sudáfrica, de más de 4.000 metros ya de profundidad, hay que ser muy eficiente, ¿no? Y eficiencia en lo que es transporte y consumo de energía, eficiencia en lo que es refrigeración, porque ventilación ya no alcanza para esas profundidades. Y es ahí que la tecnología sudafricana se ha desarrollado mucho, ¿no? Para estas condiciones, que creemos que se pueden adaptar de alguna manera y sacarle un gran provecho en la industria minera peruana, ¿no? Bueno, me queda solamente agradecer a Jim y a los especialistas de Somerset, a Henry, a Vivek, a Quentin, a Derek, ¿no? Por su excelente presentación. Muchas gracias a todos, y cualquier otra pregunta que quieran hacer en el futuro ya tienen sus contactos y dirigirse directamente a ellos, o quizás a través del capítulo de Ingeniería de Minas para ayudarlos con el idioma. Bueno, si no hay nada más en la agenda, bueno, voy a dar por terminado esta serie de conferencias.
Si me permite, Juan, una última palabra.
Por supuesto.
Quisiera simplemente mencionar que hace 2 años teníamos un proyecto de organizar una misión comercial, técnica comercial a Sudáfrica, y quisiéramos tratar de retomar ese proyecto para el año 2022 para participar en la conferencia Electromining de África en el 2022, que es la conferencia similar a a la que a Perumín, y que reúne a los productores de minería, de industria, de construcción y de la industria eléctrica. Así es que esperamos poder colaborar con el Colegio de Ingenieros en este tema y organizar esta conferencia para el próximo año.
Ok, don Guillermo, sí, hace años se hacía, fui uno de los organizadores de estos viajes a Sudáfrica y siempre hemos sido bienvenidos por toda la industria sudafricana, ¿no? Okay, guys, thank you very much. Hope to see you next summer. Keep well. Well, otherwise, we hope you can come this time to our country. No? Cheers.
Muchas gracias, Arturo.
Buen día, muchas gracias.
Thank you.
Thank you.
Chao, chao.
Thank you. Yeah.
Bye. Goodbye and thank you.